Good evening, Mustangs. Welcome back to another edition of No Here, No Problem. Today we've got section 2.3, which is notes related to real zeros of polynomial functions. This is going to be a long one again. It's a doozy, but it should serve as a review. So if at some point you're like, I know how to do that, go ahead and fast forward. But in this section, we're going to talk about factoring using synthetic division. We're going to use long division. We're going to use quadratic formula. We're going to use Desmos. We're going to kind of do all that, okay? So just be ready for what's coming. Again, if you understand what you're doing, feel free to fast forward, okay? So let's get started here. First thing I want you to know is that when we're talking about factoring a polynomial, we're saying what are all the factors and then how many zeros are there? And when we look at the degree of our polynomial, that 3 that we see right there in this tells us that there are supposed to be 3 answers for this. There's supposed to be 3 factors or 3 zeros, but no matter what, there's supposed to be 3 solutions for this. Now, in this section, we're only going to focus on real solutions. Later on, we're going to focus on imaginary solutions. So let's try doing this one. It says factor. Let's talk about the only method that you guys have when it comes to factoring, and that's simply using the grouping method. If I try to take and group these together, that's the standard way we're going to do this whenever you have 4 terms. If I factor out an x squared from this first part, and 6 and 19 have nothing in common, we're just going to be left with the 6x minus 19. If I take a 4 out from the second part, we're going to be left with a 4x minus a 1. Now the grouping method is supposed to be used when I have 4 terms, and usually what ends up happening is this 6x minus 19 and that 4x minus 1 end up being the exact same thing. And that usually allows me to factor out the 6x minus 19 or the 4x minus 1. In this case, it doesn't work. So what do we do when I can't simply factor this and I know that I have to? This is what we're going to start with, is move on down here to long division. Now we'll get there, but let's make sure that we remember how to do basic long division from when we were in elementary school, okay? So if we think about long division back in elementary school, let's say I had 1024, and we take this, and we're going to go ahead and divide it by 5. Now the process for long division is the same thing. It's just over and over and over and over. This is what we're going to do with polynomials as well. We're going to do this long division process. So first thing we always do is we look and see, does this 5 that we have right here, does this work nicely with the 10 or with the 1 that we have right here? Does 5 go into 1? And the answer to that is no. So then we say, all right, well, let's try the next term. Let's try 10. Does 5 go into 10? And the answer for that is yes. When we do 10 divided by 5, that equals 2. So we put a 2 there. After we're done doing the division, we do multiplication. So we take and we multiply the 2 and the 5. These get multiplied, and that's going to give me a 10. After multiplication becomes subtraction. When we do subtraction, we go straight down. Once we're done with subtraction, we bring it down. We have the 2. And then the next thing we're going to, what do you need?
Hole punch.
The hole punch?
Sorry.
That's all right. And then the next one we're going to do is we're going to see how many times does the 5 go into this 2 that's there. Does 5 go into 2? The answer is no. So what we're going to do is we're going to put a 0 right here. And then we continue. Since it didn't work there, let's bring down the next number, a 4. How many times does 5 go into 24? And what happens is we know that it's going to go into it a total of 4 times. It doesn't go into it a full 5, just a total of 4 times. So let's put that 4 right there. Let's again do the process of multiplying these 2 numbers together. So we're going to multiply this, and that's going to give us a 20. Subtract, and we end up with a 4. Now, when we look here, there's nothing left over here for me to bring down. We're not going to worry about decimals and all that stuff. There's nothing left for me to bring down, so we're done. This value that we see right here, that 4, that becomes known as a remainder. So how do we write remainders? Well, the way that you write remainders in the past is you probably have done like R4, right? Well, we're not going to do that. We're going to do the actual proper way of doing this, which is to say a 4 over a 5. And so we say it's the remainder divided by the divisor, okay? And the divisor in this is our 5 that's taking place in this problem. That's our divisor. Okay? So that's the process for long division. Let's see if we can actually take and apply that to a simple problem like this. Okay? So when we take this and it says, use your calculator to find any zeros that we possibly have in this picture, and then we're going to use long division to rewrite f of x as a factored product of the zeros. Whoa, a lot of words there, but let's just take a look at what the actual graph looks like. So if we go to our calculator and take a look at the graph, that first graph that we have in there is the 6x cubed minus 19x squared plus 16x minus 4. And we look at this, we can see that when I look at the overall picture, it's x cubed, so it's got that odd function thing where it goes up and to the right, down and to the left. And then let's zoom in on the zeros, because that's really what we're focused on here. You can see from this picture that we have 3 separate times that my graph hits this. And remember, the degree says they're supposed to be 3. So when we look at this, we can see one of those is at 1/2. One of those is at 0.667, which is 2/3. And one of these is at positive 2. Now, of these 3, only one of them is a really nice, clean number. So let's use the 2. Okay? We don't want to work with wonky numbers. Let's work with clean numbers. So let's work with that 2 that we see there. Okay? So if we work with that 2, let's start over again with what we were just doing. I'm going to try to stay as organized as I can with this whole process so we can really see this, okay? 6x cubed minus 19x squared plus 16x minus 4. And here's what we just found. We said that x equals 2 is a 0. We have a 0 at x is equal to 2, okay? That tells me that one of my factors for this is x minus 2. Okay, we talked about that in our last section here. So let's use that on the outside of this and see if we can do long division. Now, how do we do long division with this? Well, we're not going to focus so much on this 2 that's right here. We're going to actually focus on the x. And we're going to see how many times does x go into a certain value. So I'm going to go ahead and highlight this in orange. Now let's do purple. Sorry, I'm going to go purple. This x right here. And what I'm going to do is I'm going to go ahead and see how many times does x go into 6x cubed. So let's do that off to the side here. How many times does x go into 6x cubed? And when we reduce this, that 6 stays the same. That x cubed divided by x just leaves us with the x squared. And so what we end up with is a 6x squared right here. Now, just like in normal long division, we're going to go ahead and multiply out this whole thing. Okay? And if we do that, we're going to take and we'll multiply the 6x squared, but it's going to multiply by this entire thing that we see right here. These two do multiply. And so what happens when we multiply that? Well, we're going to have a 6x cubed, and then we have a minus 12x squared. Okay? Now, if you remember when we did long division, again, we're going to go ahead and we're going to hit, we're going to go ahead and do subtraction next. So since we're doing subtraction, we're going to say minus this whole quantity that we see here, the whole thing. Now, I don't like doing this. Generally, because we have a minus there, I just say to myself, we're going to distribute it to everything that's going on there. So what I do is I go ahead and just simply say, whoops, I just erased that. I simply just say, take the opposite of everything we just put out there. So opposite, opposite. And then we just add straight down. So what happens is those 6x cubes are going to go ahead and cancel themselves out. And if we go straight down with this next part here, this next part here is going to go ahead and leave us with a negative 7x squared. Okay? Now we're going to do like we do in long division. We're going to bring that 16x down. And then what we do is we start all over. Same exact process, but this time now we're going to work with the next number. Now we're going to look at the 7x squared that we see here. And we're going to see how many times does x go into 7x squared. So we're going to go negative 7x squared. How many times does x go into it? We end up with negative 7x times. Okay. We take that value and we multiply it, just like in long division. We're going to multiply it by the quantity that's over there. And we're going to end up with a negative 7x squared and then a positive 14x. Okay. Like I just said in the previous part, I know I'm going to have to distribute a negative throughout this, so I just take the opposite, opposite. And what's going to end up happening is the 7x squares will cancel, and we're going to be left with 16. When we look right here, 16 minus 14x is going to give us a 2x. And then I go ahead and I bring down the minus 4. Okay. And then we start all over again. So we're going to see now how many times does x go into 2x. Okay. And so let's go ahead and check to see how many times that occurs. How many times does x go into 2x? That simply is equal to 2. And so we're going to be left with a plus 2 here. We're going to take and distribute the 2 to that quantity over there. And we're going to be left with a 2x minus 4. And then just like in the previous parts, we take the opposite. So opposite, opposite, and we net a 0. Now we get a 0 as the remainder because we know it is in fact one of my zeros. There shouldn't be a remainder. Excuse me. There should be a remainder. Again, we notice right here, it's a nice, clean, perfect number. No remainders when it's a factor. When it's a factor, there's no remainders. We'll talk about that more in just a moment, okay? So since there's no remainders, here's what we're left with at this point, okay? We now have this quadratic up here. Once you've gotten it down to a quadratic, your job is to try to figure out what are my other zeros. And the only way you can do this is to factor it, quadratic formula, whatever it might be. Now I'm going to try to encourage you guys to do factoring as much as possible, okay? If you can factor. And if it's one of those where the leading coefficient isn't 1, that's okay. Practice makes perfect with this. You're going to be slow until you can get faster. So you're going to crawl before you can run when it comes to doing guess and check. Here's what I mean by guess and check. We know that the factors of this 2 right here has to be a 1 or a 2, right? There's no other options. It's got to be a 1 and a 2. Now, when we look at this 6, there's several other options. That one's a little bit more challenging. It's 1 and 6, 2 and 3. Okay? Now, I'm going to tell you from experience, 99% of the time, it's not going to be the 1 and the 6. So I'm going to try the 2 and the 3 first, and let's just see what happens, okay? Let's see what happens when I throw the values out here. If I put a 2 and a 3 here, I'm just guessing, and now we're going to check. This is going to give me a 4. This is going to give me a 3. Now, I need to get a negative 7. That's that value that's in the middle there, a negative 7 right here. So the only way that I can get a negative 7 is if these are both negatives. So that means that this would have to be a minus and this would have to be a minus in order to yield those negatives that are there. And let's just finish checking everything to see if we guessed and checked and we got the right values. If I go ahead and distribute this out, the 3x times the 2x will give me that 6x squared. We end up with a negative 4x and a negative 3x, which is negative 7x. And then we have a negative 1 times a negative 2, which gives us a positive 2. So we guessed and we got it right. Here's what it looks like if I guessed and I did it wrong. I'm just going to take those and switch the 3 and the 2. Now, don't do anything. I'm going to fix it. But what I want you to notice is right away when I put that 2 in here, you can see how like there's a GCF right here. That usually doesn't happen when we're doing a guess and check because at this point we've already taken a GCF out. Okay? So let's go ahead and put those back to the way they were. It was a 2 and a 3. There you go. It says to factor this, we've got the factored form. So here's my final answer for this. We've got that x minus 2 that we started with from here. And then we've got 2x minus 1. And then we've got 3x minus 2. There's the factored form. And if I was to say, well, what were the zeros for this? The zeros we can quickly solve are 2, 1/2, and then 2/3. Now let's go back to our picture. If we go back to our picture, look at what we said were the zeros. We said 2, which we got here, 1/2, which we got there, and then 2/3, which is that 0.666667. That's 2/3. There's our 3 answers. Okay. All right. So let's continue on here. So how do we write these out? Well, the long division leads to answers where we've got 3 parts that you have to write out. You have that q of x, which is the quotient. You have that r of x, which is the remainder. And then you've got that d of x, which is the divisor. So you've got the quotient, the remainder, and then you've got the divisor. Okay? This is the generally accepted form that we're going to write our answers. Okay? So let's look at a problem like this, where we say 3x to the 4th minus 2x to the 3rd plus 5x squared plus 2x minus 10. And we're going to try to go rapid fire with this, okay? Slow it down, go back if you need to. I'm going to try to expedite things here a little bit, okay? So looking at this problem, the degree tells us that there's going to be 4 zeros and that there's supposed to be 4 factors total when all is said and done, okay? I don't know if that's the case, but it doesn't say in the directions here to factor this or find all zeros. What it says to do is to go ahead and do long division to see what ends up happening when we divide the one by the other. Now, I'm going to tell you right now, I hate long division. I will never do long division unless I'm absolutely being forced to. And the only time we're ever forced to is when this value right here, that x minus 1, is not linear. If it's like an x to the second power or some other weird wonky value, you have to do long division. But when it's just a linear value of like x minus 1, I would totally use synthetic division for this personally, which we will get to that in a few minutes here, okay? So let's go ahead, rapid fire. Let's go ahead and do long division here, just for the practice of it. 5x squared plus 2x and minus 10. And what we're going to go ahead and do is we're going to divide this by x minus 1. I start that a little bit high. I'm going to move this down. All right, we're ready? I'm going to do the work off to the side. I'm not going to color code this. I just want you to go ahead and go back if you need to see it, okay? We're going to first see how many times does our x go into 3x to the fourth. So 3x to the fourth, x goes into it 3x cubed times. That 3x cubed, we're going to take and distribute it to the quantity on the left side there, and we're going to have 3x to the fourth minus 3x cubed. We take the opposites of the values we just wrote, and we're going to be left with just 1x cubed and a 0 over on this other part, obviously. We bring down the 5x squared. We're going to see now how many times does x go into x cubed. So x cubed, how many times does x go into it? And we're left with x squared. So I'm going to write plus x squared. We'll distribute that out. We get x cubed and then minus x squared. We're going to take the opposite, and that's going to leave me with 6x squared. And obviously a 0 there. We'll bring the 2x down. 2x divided by x, so we're seeing how many times does the x go into that. Nope on a rope. Hang on a second, wrong value. To 6x squared. Sorry, 6x squared divided by x. How many times does x go into that 6x squared? We are going to be left with a 6x for the value there. So let's go ahead and write 6x. We'll distribute that out. We get 6x squared and then negative 6x. We take opposite. We're left with 8x. Bring down the negative 10. And the last one we're going to see how many times does x go into 8x. And that's just 8 times. And we're going to have an 8 here. So now we're left with 8x minus 8. And then we're going to do opposite. We're left with a negative 2. Now this value right here, that is our remainder. There's nothing left for me to bring down to this problem. We're officially done bringing everything down and doing all the parts that we need to. So now we just need to write this in its standard form. So we're going to have the quotient, which is 3x cubed plus x squared plus 6x plus 8. That's our quotient. Plus the remainder, which is negative 2, over the divisor, which is x minus 1. Now, I don't like using double signs, so where you see right here we've got the plus minus, I'm going to go ahead and just rewrite that so it's just equal to a minus instead. There you go. That would be our answer when we do long division for this. Okay? All right, let's continue on here. Let's do another example. And this one is different. When you noticed here, look at the degrees on these. We got 4, 3, 2, 1, and then we have no x. There's an 1 here, and then there's technically an x to the 0 power. And when we look at this, it's got all the degrees accounted for. You got 4, 3, 2, 1, none. Anytime you're doing long division, anytime you're doing synthetic division, anytime you're going through and doing this, you have to make sure that all the degrees are accounted for. The reason being is that you notice how as we're doing our work, you can kind of see that the x to the fourths line up, the x to the thirds line up, the x to the seconds line up, the x's line up, and then the constants line up. If you don't have those values in there, you don't have things lining up, and things just kind of get all over the place. So let's look at this problem here. Clearly, we've got things missing. So let's go ahead and rewrite this in the way that we really need it to be, which is with all the values accounted for. We have, when we look at this, negative 2x cubed. We're missing an x squared. So what do we use to fill that value in? Well, there's no x squares, so we use 0 x squares. And when we continue on, we end up with a 3x, and then the number that everybody forgets is when there's 0 x's. So we say 0x to the 0. Now you don't have to say 0x to 0. You really could just simply say, let's go ahead and just throw a 0 right here, and just keeps everything lined up now. And we're going to go ahead and do our long division. I'm going to rapid fire this bad boy now. I'm not going to do the work off to the side. This time, let's just quickly work through it. X goes into negative 2x cubed, negative 2x squared times. Distribute that out, we end up with a negative 2x cubed minus an 8x squared. Notice how the x squared is lined up now. Okay. We'll take the opposite, and we're left with the 8x squared and a 0 here. We'll bring down the 3x. X goes into 8x squared, 8x times. That then is going to equal 8x squared plus 32x. When we distribute that 8x to the quantity on the left, we're going to go opposite, and we end up with a negative 29x and a 0, of course. We'll bring down that 0, and x goes into negative 29x, negative 29 times. Distribute it, we get negative 29x, and then negative 116. Okay, opposite, and we're going to be left with a positive 116. So this is our remainder. Let's go ahead and rewrite it the proper way. We end up with a negative 2x squared plus 8x minus 29. That's our remainder. I'm sorry, that's our quotient. Plus 116 divided by, so that's our remainder, over x plus 4, which is our divisor. You have to make sure that you have this plus in between. Just like in the previous one, we had that minus there. Okay? All right, so let's get to the thing that I personally love to use, synthetic division. Synthetic division can only be used when we have a linear quantity over on the side here. So again, this method is called synthetic division. Okay. And you literally follow this little down, up, down, up, down, up, down, up pattern. Okay. It's real simple. If you haven't done this before, it's real simple. Here's how synthetic division works. We are going to take the value that we see over here on the side, this x plus 3, and we're going to solve for it. And so when we solve, we end up with x is equal to negative 3. That's the value that we're going to go ahead and put over here when we're doing the synthetic division. Okay, we're going to put that negative 3 there. And what we're going to do is we're going to go ahead and just work our way down, up, down, up, down, up, down, up. Now for the first step, you always just take the 1 that you see in the problem there. Whatever the values you see, you bring that down. So whatever number is right here, that value goes straight down and becomes the same value right there. Now, this process is, you got to watch this is visual, multiply these two numbers together. When we multiply those two together, that's going to give us a negative 3, and that's what's going to go right here. Okay? So that's going to be a negative 3. And now what we're going to do is we're going to add. So we're going to add straight down here, and when we add these together, we end up with a negative 3. That's adding these together. Okay? And so we're going to have a negative 3 here. Now you start over. You're now going to multiply these two together. And that's going to give us a positive 9. Okay, and when we do this, we're going to be with a positive 9, and then we go ahead and we add these together. So negative 10 plus 9 will give us a negative 1. Okay, so we end up with a negative 1, and then we're going to continue on. We're going to multiply these together. That's going to give me a positive 3, and then we're going to go ahead and we're going to add these together, which will give me a positive 1. All right, and then we're going to go ahead and multiply these together, and that's going to give me a negative 3. And then we're going to go ahead and add these together, which will give me, now this was a negative 3, which will then give me a positive 1. Now, what does this actually say? What is going on here? All right, where did all these numbers come from, and where, in God's sakes, does this actually say? Well, you have to pay attention to what are the values that we start with in our problem here. Do you see right here how in front of our x to the fourth, there's really technically a 1 right there that we don't write? That's where the 1 is. If we continue on, you can see that there's a -10, a -2, a +4. And then on top of it, there is an x cubed that is missing here. There's an x cubed that's missing in here. And so what do we do when we say there's no x cubed? We say that there are 0 x cubes. Again, you need to make sure that you have all the degrees accounted for. So 4, 3, 2, 1, no x. And now look at the values that we have in here. We've got a 1 and we've got a 1. We've got a -10 and a -10. In between there, you had that 0 that was missing. You've got the -2 and the -2. And then you get a +4 and +4. Okay? And then what does this actually say? Well, if we started with x to the fourth and I divided, we drop it down 1 degree. Just take a look at these problems. I started with an x to the third and I divided, I end up with an x squared. I start with an x to the second, I end up with an x to the first. I keep dropping it down 1 degree when I divide. So when we look at this said x to the fourth, now the problem says x to the third. This said x to the third, now it says x to the second. This said x to the second, now it says x. It drops 1 degree. This says x to the first, now it's x to the 0, which that means I don't have to write the x. And this guy right here, this is the, oops, I gotta pick the right thing. This is now the remainder. Okay, so let's write this out. We have x to the third minus 3x squared minus x plus 1 plus 1, my remainder, over my divisor, which is x plus 3. A lot faster than doing the long division up above. Okay? All right. So let's do another thing with synthetic division, and it's something related to what's called the remainder theorem. Now I want you to show you what's actually happening here and how fast this actually is for us. The remainder theorem says that if I take this x and I plug it in, my remainder when I do synthetic division is going to actually be the same as if I had plugged it in. It's like a shortcut. It's crazy. So if I take 3 and I plug in a -2 to the third power, plus 8 times -2 to the second power, plus 5 times -2, and then minus 7, what do we end up with? Well, this right here is going to be 3 times -8, plus 8 times 4, minus 10, minus 7. This is -24 plus 32 minus 10 minus 7. That means we're going to end up with an 8 minus 10 minus 7, which is -2 minus 7, or a -9. Whew, we got there. And again, all that's without a calculator, right? But I like doing things without a calculator. And synthetic division, when I'm evaluating, is actually one of the fastest ways to do it. At least for my brain, it is. So when I look at this, watch what happens when we do synthetic division. I want you to focus on this last number right here, okay? We're going to set this up, look at the degrees, make sure we got them. So we got 3, a 2, a 1, and then none. So we've got all degrees accounted for. We've got 3, 8, 5, -7. The value that we're going to test is this -2 that we see right here. So we're going to put a -2 right here. All right, here's the process. Ready? Bring down. Multiply, we get -6. Add, we get 2. Multiply, we get -4. Add, we get 1. Multiply, we get -2. Add, we end up with a -9. Done. Boom. Boom shakalaka. That is Skibbity Rizzo, Ohio, Sizzler, whatever you want to call it. Okay? -9 and -9 right here. It's the same thing. Significantly faster, in my opinion. Okay? So, what is it we're really doing? Well, the factor theorem says that if we end up with no remainders whatsoever, then the quantity that we use is actually a factor of my original function, which means it's also technically one of my zeros of my function. What am I talking about? Well, let's take it back to what we do know, okay? If I ask you a question, is 3 a factor of 15? What would you say? You say yes, right? because 15 divided by 3 equals 5. There's no remainder on it. And because there's no remainder, we can say that it's a factor. So same question, is 3 a factor of 14? Well, if I do 14 divided by 3, we end up with 4 2/3. And because it doesn't divide evenly, we have a remainder. That 3 is not considered a factor. Well, how does that help me when I'm doing problems like this? Okay, let's take a look. If I'm going to do, and I can use synthetic division because these are linear, watch what's going to happen here. Okay, I'm going to go ahead and we're going to start with the values that we see there: 2, 7, -4, -27, and -18. And again, make sure all the degrees are accounted for. 4, 3, 2, 1, none. So we're good. Let's test my zeros here. This x is going to equal 2 if I was to solve it. So let's put a 2 right here. And if all goes well, if this value is actually a factor of this, I shouldn't have a remainder. There should be a 0 in that very last spot. Let's see what happens. Bring the 2 down. We get 4, 11, 22, 18, 36, 9, 18, and 0. So that 2 actually is a factor in this problem. Okay, let's continue. Let's see if that 3 that's there is also a factor. Now I can continue dividing. Just like if I was to go ahead and say 36 divided by 6, and I say, is 36 a factor? You'd say yes. Well, I could say this, 36 divided by 2 times 3, because 2 and 3 multiplied equals 6, right? They're the smaller parts that make up that value, that's 6. And I could do 36 over 2 times 3 and do these first, which will give me 18 over 3. And then I don't have to start over. I continue with that smaller number, and we get 18 divided by 3, which is a 6. So that's what I just did here. I created a smaller polynomial. I'm going to continue with that polynomial. So that x in this next part is going to equal -3. So we have x minus 2, which gave us that x is equal to 2. We have x plus 3, which gave us that x is equal to -3. And let's test it. Again, we should end up with a 0 here now. Let's see if that happens. Bring down the 2. We have -6, 5, -15, 3, -9, 0. All right, so where are we at here? And I'm ready to start doing other tools. Well, when we look at this, we started with an x to the 4th power. We divided, we went down to x to the 3rd power. We divided, now we're down to x to the 2nd power. So what this technically says is 2x squared plus 5x plus 3 is equal to 0. Now you can go ahead and try factoring. You can go ahead and do quadratic form. You can do whatever you want, but we're trying to get the residual answers here. Try, guess, and check. The only factors that we can have for this 2 are a 2 and a 1. That's all we got. The only factors that we can have for this 3 are 3 and 1. So let's guess and check. Now I'm going to do this intentionally wrong, so watch. We're going to have a 1 and a 3. Let's see what happens here. This would give me a 6. This would give me a 1. The only way I can get a 5 from those two numbers is if I actually end up with a 6. Whoops. If I end up with a 6 minus 1. And that would mean that this would have to be a minus, this would have to be a plus, and so on and so forth. Right? It gives me a 5, but when I go back and check the values, you'll notice right here, this is why we call it guess and check. These two values right here will give me a -3, but I've got a +3 here. So we don't want to use those values there. Let's try rearranging this and see what happens. Let's go ahead and put, instead of the 1 and the 3, let's go ahead and put a 3 and a 1. Just take those two and just swap their positions. Now we end up with a 2, a 3. To get a 5, I do plus for both of those. And that would mean that this is what it's going to look like. Okay. And that means that the other factors for this would be 2x plus 3 and x plus 1. That would mean that x equals -3 over 2, and that means that x equals -1. We've got 4 factors. There's 4 zeros. The degree right here told me there were 4. My answers are 2, -3, -3 over 2, and -1. let's confirm this. Take a look at our picture here. I'm going to turn this one off and turn this one on and take a look. So it is an even function, okay? When we look at this, you can know it's got that even function, that 2x to the fourth that's there. The leading term is positive. We know it's going to be going up. And you can see, zigzagging here, there are 4 different zeros in this. Ready? Here's the first one at -3. Here's the second one at +2. Here's the third one at -3/2. And here's the fourth one at -1. These were the zeros that we said were part of my answer. And let's look right here. Same exact 4 answers. Okay? All right. So this pretty much concludes everything that we just did. I want to go back and show you one more thing here, though. Remember when I said I prefer synthetic division over long division? Take a look at this problem right here. Now I'm going to erase all of the work. I'm going to show you the answer for this in a much faster way. You ready? I'm going to get rid of this. I'm going to go ahead and get rid of all this. No, I don't want to get rid of all that. I'm going to get rid of all of this is what I mean. Sorry. Okay, and I'm going to leave that answer down there, and I want you to watch how much faster this is than long division. You ready? 3, -2, 5, 2, -10. Just to confirm, we have 4, 3, 2, 1, none. The value we're going to use here is x is equal to 1. Ready? Bring down, multiply, add, multiply, add, multiply, add, multiply, add, done. Now, take these answers that we see right here, take these values, I'm going to duplicate these, and look at what ends up happening right here. 3, 1, 6, 8, -2. Synthetic division for the win, baby. That is it, Mustangs. This concludes our lesson. Feel free to like and subscribe to my channel if you liked what we did here. Otherwise, you guys take care, be safe, be responsible, and have a good one.